Today we're going to talk about boiling point and freezing point changes. How's that? So what's going to happen is when you add something to water, it will change the temperature which it freezes at or the temperature which it boils at. And that change has some variables associated with it. In some cases, if you look at ionic compounds, it'll change it a little bit more so than if you look at molecular compounds. So when we look at the stuff, and again, it's the difference in the change in temperature from what it normally boils at. So we'll be using water for all of this. What temperature does water boil at? 100 degrees. And water freezes at 0 degrees. Celsius, very good. So what that means is if we add something to the water, it'll raise the temperature in which it boils at, or it'll lower the temperature which it freezes at. And this is kind of important because that's one reason why we throw salt on the roads in the wintertime. Why do we put salt on the roads in the wintertime after, say, a snowstorm or something? Melts ice. It actually lowers the temperature in which ice freezes at, thus melting it. Very good. So we lower its temperature in which it freezes at, and then it just melts away. Now, there was a couple years ago where we had the negative degrees for almost a week. Putting ice on there was just like wasting money because it was too cold. So no matter how much salt you put on there, there's an upper limit to how much you can put on there, but it wasn't doing anything. That's why we missed a whole week of school. Putting ice on ice would not be good. All right, so what we're doing today is actually looking at the new temperature at which it either boils at or freezes at, based on that information. You're going to see here. All right, so, and there's another thing, too. These colligative properties associated with it, it's, actually, let's talk about electrolyte first. What's an electrolyte? Here's an unfinished Powerade that Sam was drinking. I'm so glad he left it here. But it claims it has electrolytes in it. What's an electrolyte? It helps with that. It does not give you power. It does not give you energy. It does not give you sugar.
Helps you recover.
How does it help you recover? When you sweat, what do you lose other than water? Yeah, but what are electrolytes?
Sweat.
Okay. Here's what I want you to do next time you sweat. Okay. This is your experiment. Kind of a disgusting experiment, but sweat and then let it dry without taking a shower. And then lick your arm. It'll taste salty. Yeah. It's yours. It's okay. So what it is, it's replacing ions. So when you sweat, you lose like magnesium and sodium and all those other ions that are essential for your nerves to carry an impulse. If it doesn't have electrolytes, well, your nerves can't carry an impulse, and guess what? You get to die. From water? Not unless it's been fortified with it. Yeah. So when they talk about electrolytes, what I really care about is that it's an ionic ion, or compound. Is not a recovery for you. Yeah, it helps to replenish water, but it doesn't do anything for the electrolytes.
So in order to get both, you have to drink water and that thing.
Yes. So during the day, you eat your normal food. That puts electrolytes into your body. To recover, the best thing to drink after you do a workout is what? Chocolate milk. Very good.
Wait, what?
Yeah. The best recovery is chocolate milk. Because it has sugars, it has proteins, it has electrolytes. Trust me, it's the best recovery.
Yeah, I saw that.
I know.
What about mercury?
Oh, always drink mercury. Yeah, yeah. All right, so colligative properties. When we talk about looking at a compound,
Gotta always eat that fish.
when we're looking at compounds, you have to know if you're looking at an ionic compound or a molecular compound. Now, how are you going to know if you're looking at an ionic compound? It has a what and a what? Yeah, a metal with a nonmetal. Good. So when you're looking at, say, sodium chloride, you have a metal, which is on the left side of the periodic table, with chlorine that's on the right side. So you have an ionic compound. It's not the size that matters. It's the number of particles. Okay. So like glucose. Glucose is a big molecule here, but it's a molecular compound. So it doesn't change. If I had 1 mole of glucose and 1 mole of sodium chloride has more punch in the change in which it's going to freeze or boil at. So when we look at molecular compounds, just like when you had your quiz, when you had carbonate, how did that break apart when you put it in your solution? It didn't. It stayed together. Very good. Because technically, even though it's a polyatomic ion, it's molecular in nature. Okay? So never tear apart molecular compounds. Okay? All right. Here are 2 equations that we'll be using today, and they look very similar to each other. Okay? And you'll notice that it starts off with a delta T. That's the change in the temperature at which something's going to boil at or freeze at. Notice how I have the B and the F there. That wasn't my sneakiness there. The I is actually called the Van Hoff factor, and that actually is later on in the notes, but I'm going to talk about it now. The Van Hoff factor is a multiplier. So if we go back to, just a little bit back here, looking at glucose. If I start off with 1 molecule of glucose, when I place it in water, it remains as 1 molecule of glucose. The Van Hoff factor for that is 1. If I start off with sodium chloride and I have 1 molecule of sodium chloride, it'll break apart into sodium ions and chlorine ions, and it'll give me 2 ions. The Van Hoff factor in that case would be a 2. If I had calcium chloride, if I had 1 molecule of that, it would break down into 1 mole of, or 1 ion of calcium and 2 chlorines, which gives us a total of 3. What do you think the Van Hoff factor is? 3. If I gave you, say, something that looked like this, calcium phosphate, and I asked you to tell me what the Van Hoff factor is, you would say it is 5. Because it'll break down into 3 calcium ions and 2 phosphate. Okay? So that was one reason why we did the net and the ionic and net ionic equations, so you could get these breakdowns. So in that case, the Van Hoff factor would be 5. Sound pretty easy? That actually was the second half of the lecture, sadly. All right. Now, let me talk about the 2 equations. Okay. What is that? Next screen. Okay. So, again, the delta T is your change in temperature in which the substance boils at. So, if we boil water at 100, then it'll elevate that temperature. The K sub B is a constant, and it'll be given to you. Okay. All constants will always be given to you. You just have to know which one to use. So, if you're going to do boiling, then we use this guy here. What in the world? If we boil, this is the one we'll use. If we're freezing, this is the one we'll use. And notice that the units are in degrees Celsius per kilogram divided by mole, which is the opposite of molality. What's the unit for molality? Mole divided by kilogram. So that when you put those 2 together, what happens to the unit mole? Gone. Kilogram. Gone. And so you're left with degrees Celsius, which is our change in temperature. Okay, cool. There is no unit for the multiplier. So there is no unit for the multiplier, which I know it's going to drive some of you crazy. And I apologize in advance. I didn't make the rules. Write what down? They're given to you. Oh, you don't have paper. You don't have your computer. All right, hurry. All right. Let's do an example. So looking at practice problem number 6. Okay. Question asks, calculate the temperature in which a molecular solution, so is this ionic or molecular? The reason why I ask that is because some will ask, is this a molecular compound or an ionic compound? And I will say it's molecular since it says that. Will boil when the solution contains 45.9 grams of the molecular compound, which we don't know about, don't care about, because it gave the molar mass as 56.32 grams per mole, is placed in 1,340 milliliters of water. All right, so first things first. Are we looking for a new boiling point or a new freezing point? How do you know?
Because it says boil.
Will boil. Good. That's good clue there. So our equation that we're going to be using is this. And molar. Okay? So delta T is our change in temperature. So we want to find out what that new change is. And what is the I? Did I tell you what that I, the name of the I is? What is it? Van Hoff? Did I say that? Okay. So what is the Van Hoff factor for this solution? I'll give you a hint. 1. Anytime it's molecular, it's always 1. Why? Because it doesn't dissociate, it only dissolves. Dissociation means that it breaks apart into ions. When it dissolves, it stays as a molecule, which is kind of nice. And are we boiling or freezing? Boiling. So the constant for boiling, is it the 0.51? Thank you for the confirmation. Thank you. Okay. And then molality, how are we going to find out what the little m is here? Yeah, so you got to find out what it is. So to find out molality, we have to find out, first of all, how many moles per kilogram. How are we going to find moles of this? There you go. So we have 45.9 grams. Let me scroll down a little bit here. Get some space here. So we have 45.9 grams. So 45.9 grams. And the molar mass for this is 56.32. So you don't have to worry about what the compound is. So 815. Anybody else get that? Ish. I did stuff, yeah. So now I've got this. I'm going to go ahead and just plug it in here. And then how can we find out how many kilograms of water we have? Okay, let's do this. So remember that. Here, let's go to a different color. So 1 milliliter of water has a mass of what? 1 gram. And how many grams are in a kilogram? 1,000. Good. So remember those. Good. So if you needed to see it, I know there's some of you out there. 1 milliliter, 1 gram, 1,000 grams. So that would give us 1.34 kilograms. Okay. So looking at the units, who can cancel out here? Mole, kilogram. What remains? Degrees Celsius, which is our temperature, and then have some fun with that. Now, if you wanted to find out what the molality is, that's fine. You could do that. I think it's like 0.6 something. But leave it as moles over kilograms, the unit, so that they can cancel out. And I think, is it 0.31? What is it? 31 degrees? 32 is fine. It's close enough. All right, so that's our change in temperature. So what do we do at that value to find the new boiling point, or the new temperature in which it'll boil at? Plug it into what? What's the temp formula? What formula?
I don't know, I just guessed.
What's the temperature in which water boils at? Let's start there. 100 degrees. So if we're elevating the temperature, do we add or subtract? We add it. Yes, this is worth a point, so be sure to show it. I know it sounds like, you gotta be kidding me, I gotta show that? That'll be worth a point. So somebody in the first hour asked, what's the minimum I need to show? Which is always a good question. I always like to hear that. That would be the minimum. Okay. How's that? That value? What value? That is the new temperature in which this solution of water will boil at. Good. Okay. This is the new temperature in which it will boil at. And keeping in mind that water boils at 100 and that we're going to elevate the temperature, next problem we'll do, we'll freeze it and we'll lower the temperature. So it's a boiling point elevation or freezing point depression. We have another.
And it's an ionic one. This would be fun.
Okay.
This is not
It's practical conversation.
All right. So going back to the notes. So part of the homework is the fives. And then I already talked about this, so exciting. So in looking at this, we have the Van Hoff factor. This whole part was talking about the Van Hoff factor, which is our multiplier. Are there two practice? Oh, there's only one. Daggone it. However, I do want to change one thing here. I don't want it to boil. I want to find what the new freeze. Yeah, let's freeze it. All right, and I apologize. The amount of water happens to be the same here as well. You want to change that or leave it? That's not going to cause you guys to go into conniptions. What's that?
I suggest for practical
Can we just do
conversation
it random?
instead.
Nah, let's just leave it. All right.
Let's do 6B for our practical problem instead.
Okay, so looking at practice problem number 7, calculate the temperature in which an ionic solution, so the Van Hoff factor will be at least 2, could be higher, so that's why we have to find out what it is, when the solution contains 1.55 grams of calcium chloride and is placed in 1,340 milliliters of water. First thing you should do is write out what calcium chloride is. So how do I write that? CaCl2, because chlorine has a -1 charge, calcium's +2. And then when it breaks apart, you have a calcium ion and 2 chlorine ions. Now, some of you on the quiz were writing chlorine like that. That's when it's a gas. That's bad. We don't want to do that. Okay, so don't do that. These are all ions. And remember, polyatomics stay together as a poly. So the Van Hoff factor here is equal to what? 3. Very good. So you add up the coefficients. So even though there's a 1 there, you don't see it. So 1 + 2 is 3. All right, and we're freezing, so our equation looks like this. Very similar. Delta T sub F and K sub F. That should be an F, not a T. And M. Okay. So when we plug it in, so we'll go ahead and start off with our 3. And in this case, the freeze is a little bit different. Okay, the value is 1.86, where the boiling is 0.51. That would be given to you. And we need to find out, do we have the number of moles? We do not, so we need to find it. So take your grams and convert it to moles. So 155 grams of calcium chloride. Yeah, 1 mole of that. Calcium. 40.008 plus 2 times 35.45. So around 110.98. So that would be a little higher than 1 there. One point, yeah, 1.40. My calculator says 1.3966. Blah 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 blah. So close enough. Okay. So let's go ahead and so 1.40 moles. And Celeste, how are we going to find out how many kilograms of water we have?
Well, just so you take your milliliters.
Yeah, your milliliters. And how many kilograms is that? Can you do that math in your head? Yeah, I did. 1 what? 1 milliliter equals. It does. That girl, I like that. So 1.34 kilograms. Now, if you need to show that step, show that step. That's one that you can bypass. That's really the only one you can bypass. And then, when we plug all that in, 5.83. I'll type something else in. Well, I'm going to use the number that I found here. It's 5.81, so what you said, or 82? Anybody get that? 5.8 what? 3? Close enough. All right. So what do we do with that number? Subtract it from, what was it? I'm sorry? From 0. Good. So the temperature is at 0 degrees, so we have to show this. No, you cannot, unless you want to lose a point. Now, yes. Now, the reason why you have to show that is because, yes, we're only working with water, but when you get into AP, we talk about different alcohols, and they don't freeze and boil at 0. They freeze and boil at different temperatures, so we have to show that step. So it's an easy point here. What was that? I'm sorry. The homework, the 5s and the 6s.